Okay, you want your calculator handy because we're going to do log stuff on our calculator again. Hopefully you had lots of practice with your buttons. Okay, number 1. Smallville had a population of 13,000 in the year 2000, and then it grew to 19,000 by the year 2014. So I gave you this formula where P is the total population, P0 is the starting population, R is the rate of growth, T is time, and E, do you remember that value? It's in your calculator. It's 2.7-ish, da-da-da-da-da. Okay, where would I put 13,000? Is it our final population or our starting population? Starting. So I'm going to put 13,000 there for P0. And it grew to 19,000. So now that's going to be my total or final population. Times an E. Do we know the rate of growth? Use the formula to solve for the rate. So I don't know the rate times the time. How much time has passed from the starting population until when I ended this population? How much time passed? 14 years. Okay. So I'm going to start by dividing this 13,000 out. We are not allowed to round anything, but are you okay with me calling this the fraction 19 over 13? Is that okay? You see what I did? Equals e to the 14r. Okay, what's the trick to solving for variables when they're located in the exponent position? We're gonna, what is the only rule to move them to coefficients? We're gonna have to apply the log stuff. Okay, but here's the secret. When I see e's involved, what's the special log? The natural log. So I'm gonna natural log both sides. It's not wrong to log both sides, but this is going to cause something to help us out. Okay, so the ln of 19 over 13 equals 14r ln e. Okay, so the rules, exponents can become coefficients. Do we know what the ln of e value is? ln is like the same as a log e. So think about what the value is. What's the exponent that makes e result in e? Like 1. So I think I'm just going to cross it off because I don't need to times by 1. So how do I solve for r? Divide by 14. Okay, so you could do this in brackets like that, or if you wanted to, you could do that. These are the same thing, right? Because the division of something could separate with subtraction. I'm just going to go with the ln of 19 over 13 in brackets. So I'm just going to do that. Okay, and then we're going to have to divide it by 14 yet. So I get a decimal, and does that make sense? Because a rate, it's really would read 2.7% growth. So 3 decimal answer, so that's the rate. Okay, this thing is not coming off my calculator. I need it, so do not erase it. Estimate the population in 2020. Okay, so I want to know the population. It started at 13,000. So the formula is the starting population, e to the r. You see why I'm doing dot, dot, dot? It's still in my calculator. And we got to figure out the time here. So if we started at 13,000, and now we're trying to get to 2020, how much time has passed? 20 years? So 20 years from the start. Okay, so this is a lot of just calculator stuff. Here's what I'm going to do. There's my rate. Can you go times 20? So I have that exponent. Now I'm going to go e to that answer. So e to that number. Okay, you following e to that answer. 1.7 da da da. And then times 13,000. Okay, and this is population, so this, you do not go to 3 decimal places because you don't have partial people. So I'm going to answer to a whole number. Okay, but if you round that, it will throw your answer off quite a bit. Okay? If you were lost on those calculator steps, maybe when we're done this, I can come look at your calculator. What's that?
No, don't worry about it.
Don't worry about it? I'm worried about it.
I'm really good right now.
What's that? No? Did you? Why would you be so prepared? That was Tuesday. Okay, number 2. Money. Okay, you deposit $500 a month. Your account has an annual rate of 8%, compounded monthly. How long until you become a millionaire? Okay, so we have this, which is called the future value. So in this scenario, what's the future value we want to reach? How much money do we want to have in the future? $1 million. PMT is the payments. So what were we doing? Every month we were making a payment of $500. Okay, 1 plus the interest. Now here's something that might be new to some of you who didn't take essentials. First of all, 8% is 0.08. Okay, but that's an annual rate. But we're wanting to compound it monthly. So I'm going to do this, 0.08 divided by 12. Does that make sense? I'm going to have to take that interest rate for the year and divide it by 12. To the n, which is the time part. Do I know that? Nope. So that's an n minus 1 over that same rate. And I'm doing the same thing. Okay, so it's just plugging into a formula, but making sure you do remember that interest part. Annual, you'll have to divide it. If you see the word something quarterly, what would you divide by? If you see quarterly in a year, how many does that mean? 4. Okay, guess what? I'm going to do a bunch of algebra at the same time here. Are you okay if I do these things to 1 million? I'm going to divide it by 500. I'm going to times it by that fraction. And then I'm going to add 1. I'm going to do all 3 of those things at the same time. Is that okay? Do you see what I'm doing? I'm getting rid of this, this, and that. But you have to do the plus 1 at the end of it, right? So 1 million. $14.33. Okay, so that wasn't a nice pretty number, so you know what? I'm gonna have to make sure I leave it on my calculator. I don't want to ever round anything here. Okay, my variable is in the exponent position. How do I get variables out of the exponent position to solve for? I'm going to log both sides. Now we can activate our log rules, which say exponents can become coefficient multipliers. Okay, and now I'm going to isolate n. So this is a lot of just specific calculator stuff that you'll be doing here. Okay, so remember how I told you I left that on my calculator? So I'm going to do log of that, divided by log bracket 1 plus 0.08 divided by 12. Okay, so you're getting 400.7, something like that. Did it come out? But we're going to talk about what to answer here. Okay, so this is what? 400 years, months, what? What do you think it is? Months. Okay. Now, when you're making payments at the bank and you're trying to reach $1 million, does it make sense that no matter what, if this was 400.1, you would still have to round up? Because if you round down, then you would be short of money. You wouldn't have reached $1 million yet. So you'll have 401 months to get there. So you better start now, because that's over 33 years of time that you're going to be a millionaire if you keep putting $500 in the bank. But don't worry, you won't see interest like that. That's really high. Okay, so that one will always round up. Always. No matter what, okay? Okay, the next question is the one that I'm going to omit. So you'll see that in your practice. It's earthquake type. I think I'm just going to skip your earthquake type. Okay, so we're going to do this pH one. Okay, normally this formula just has a log. When it just has log, what's the secret base that it uses? I gave it away on the paper, you noticed? Okay, so if you see a log without a little baby number, right? It's really a 10 that's there. Okay, how much more acidic is a solution with a pH of 3.4 compared to a pH of 7.8? Okay, so I'm going to use this formula. The pH, so 3.4 equals negative log. Where's my chemistry people? What does that mean? Oh, I also gave that away. concentration of hydrogen ions. Okay, I'm going to divide by -1. Okay, so I have a log equation. Do you think you could move that around for me? I want it to be an exponential equation now. So the base is 10. The exponent is -3.4. And the result is the concentration of hydrogen ions. Right? Base, exponent, result. Remember all your components? Okay, so we're going to do the same thing with the 7.8. Okay, I'm okay if you've shown your work once. I'm okay if you just write 10 to the -7.8 is the concentration of hydrogen ions. Because this is the exact same stuff, right? So if you've done your work once, I'm okay if you write it, just write it the second time. Okay, so we want to compare because it's saying how much more acidic is one than the other. So when you read something like this, how many more times greater is something? What kind of math operation do you do between two things? By how much is it greater than? How many more times is it greater than? We're going to have to divide. So we're going to divide those two numbers. Which one of these numbers is a bigger number? This one is bigger than that. Okay, negative means just how many times you're moving the decimal. So if you have a number that got moved 3 decimals versus a number that got moved 7 decimals, kind of idea, right? This is bigger. So what is this divided by this? Don't worry if you do it wrong, you're going to get a negative answer. So you'll notice if you did it in the wrong order. Did anybody match that number?